Have you ever wondered why chlorine usually forms only one bond with other atoms? It's a question that might have crossed your mind during a high school science class, or maybe even while you were just pondering the mysteries of the universe. Well, let's dive into it. Imagine you're at a party. You've got a plate full of delicious snacks in one hand and you're perfectly content. But then, you spot a single lonely nacho chip left on the table. You reach out with your free hand and grab it, completing your snack selection. You're like chlorine in this scenario. You've got 7 tasty snacks, or valence electrons, and you only need one more to satisfy your craving or, in chlorine's case, to complete its octet. But what if someone offered you a whole bowl of nachos? Tempting, right? However, you'd need to put down your plate to handle that bowl, and there's a risk of dropping everything. You decide it's safer to stick with your single nacho chip. The same principle applies to chlorine. It could form a double bond by sharing 2 electrons with another atom, but that would make it less stable and more reactive. It's simply less risky to stick with a single bond. Now consider a different scenario. What if you're at that same party, but this time the last nacho chip is on the other side of the room? You spot an acquaintance closer to the chip. They have a magnetic personality, drawing everyone and everything towards them. You ask them to pass the chip and they do so. In this case, the acquaintance represents an atom that can pull more electrons towards itself, like oxygen. In summary, chlorine usually forms only one bond with other atoms because it has 7 valence electrons and needs only one more to complete its octet. Forming a double bond would make chlorine less stable and more reactive. However, when bonded to an atom that can pull more electrons towards itself, such as oxygen, chlorine can form more than one bond. So the next time you're at a party, think of chlorine. Whether you're reaching for that last nacho chip or asking a friend to pass it, remember that these simple actions mirror the complex world of atomic bonding. It's a fascinating reminder that science is all around us, even in the most mundane activities.